Welcome students. In this class we will be starting off to study about linear equations, and this is actually chapter 3 for CBSE class 10 students, and the title of the chapter is as follows: pair of linear equation in two variables. Now foremost, before we could get into the main chapter, which is pair of linear equation in two variables, let us understand what is a linear equation. Now in this particular term, linear equation, you got two particular words: linear plus equation. Now linear means, if you were to draw the graph, let me write it down here. The term linear is derived from the fact that the graph of the equation is a straight line. Okay, this is the reason. Because the graph drawn gives us a straight line, we call that particular equation as linear. Now we have got another word, equation. That would mean whatever the expression that we've got, the expression is equated to 0. So having given you that, let's move on. And another important question is, when would the graph be a linear in nature? When will the graph of the function be linear? That's the question. When would this be possible? It would be only possible if the degree of the polynomial equals 1, right? So have that in mind. So the next important concept you will have to know is with regard to the solution of a linear equation. Now when I mention I'm talking about one linear equation. Say for example, let me take this illustration. Say 9x positive 3y is equal to, say, some 21. Or remember always, a linear equation is always of the form x positive by positive c is equal to 0, where a and b cannot be equal to 0. So this is the criteria. So this equation exactly falls in line with the general form of the linear equation. And if someone were to ask you, find the number of solutions for this particular system, you have to state here that any given linear equation will have infinitely many solutions. Now what does it exactly mean? Now I have taken this system, 9x positive 3y is equal to 21. Now let me use this part of the space here. So I would be taking 9x positive 3y is equal to 21. Let me move y to the other side. So 21 negative 3y is equal to 9x. So x is equal to 21 negative 3y divided by 9. This is what we have got. Now if you were to take 3 out, this is going to be 7 negative y divided by 9, which can be rewritten as 7 negative y divided by 3 is equal to x. Now if you were to be taking values for y, let me write that down. This is x, this is y. I'm going to take values as 1, 2, 3, 4, 5, 6, 7, 8, and in this case substitute the value for y here. 7 negative 1 is 6 divided by 3 will give me 2, and then 7 negative 2 is 5 divided by 3, and then 3 is 4 divided by 3, and then 4 1 5. If I were to substitute 5, this is going to be 2 divided by 3, and substitute 6, it's going to be 1 divided by 3, and so on and so forth. Now take this value 1 and 4, substitute it here. So if you substitute the value for x and y, you should get the right hand side, right? So x value is 1, y value is 4, plus 3 times 4. So what do you get? 3 4s are 12. 12 added with 9. What do you get? You get the right hand side, right? So left hand side is equal to right hand side. So like that, you can simply go on extracting points, and there is no stopping to that act at all. So that's the reason we say that a linear system, an equation of this form, will have infinitely many x comma y. So the solutions are infinite in nature. So this is for one linear equation. But what we are going to be doing is pair of linear equation. So I will be giving you some defined notes, and it is better that you follow those notes, and then after which we will start off with problem solving, and that would give you a better understanding of the subject. So having mentioned this, let me state mathematically what a linear equation is. So this is the statement. If someone were to ask you what is a linear equation, you can use this definition. An equation is said to be linear if it can be written of the form ax positive by positive c is equal to 0, where a comma b is not equal to 0. A and b can never be equal to 0, and a comma b comma c are element of real numbers. This symbol stands for real numbers. Example of linear equations. What is the example? 10x positive 4y is equal to 31. Negative 21x positive 3y is equal to 7. So these are all some of the illustrations you can suggest. Next, what does it mean when we say solution of a linear equation? What is the meaning of this? I'm giving you the definition. This is the answer. Consider ax positive by is equal to c, right? Be a linear equation. Then for all x and y, element of R stands for real numbers. If a multiplied with x positive b multiplied with y is equal to the right hand side, then we say x comma y to be the solution of ax positive by is equal to c. So that's the basic understanding for solution of a linear equation. Example, let me give an example. Say, consider, say 5x positive 3y is equal to 30. Now, imagine they are asking us, draw this. Imagine, let me take it in this fashion. Draw this equation, linear, this is a linear equation, okay? They are asking you to draw. Now the question is, how are you going to be drawing this? What you need to do is, you need to rewrite this like in this fashion. Consider, okay, I'm writing the solution here now. Consider 5x positive 3y is equal to 30. I'm going to rewrite it as 3y is equal to 30 negative 5x, and then y is equal to 30 negative 5x divided by 3, which can be written as 10 negative. In fact, you can write it like this, 10 negative 5 over 3 times x, or you can simply state it like that. Okay. Now first we need to get the x-intercept. So you can either start with getting the x-intercept or with the y-intercept. I think y-intercept will be much easier. So step number 1, let me write that down. Get y-intercept. So for that, put x is equal to 0 in 2. So I'm going to take this as 2. You put x is equal to 0, you get y is equal to 10. Now step number 2, you get x-intercept. Okay, put y is equal to 0. So you have 0 is equal to 10 negative 5 over 3 times x. So therefore 5 over 3 times x is equal to 10. So you multiply 3 to the right, you get 30. You bring 5 down, this is going to be x is equal to 30 over 5, which is equal to 6. Therefore x is equal to 6. This is the answer. Right? So how are you going to plot? This is 0, 1, 2, 3, 4, 5, 6. So you got a point there. And then 10, I'm taking it as 2, 4, 6, 8, 10. So there is a intersection here. And 1, 2, 3, 4, 5, 6, there is an intersection here. So we can actually connect these 2 points. And you can clearly see the line will be moving on, and this part also the line will be moving on. Right? They will be heading on. There is no end for these lines of this fashion. So the line will be heading up and heading down. So this is the graph, and that's the reason I said, if this is the system given, say the equation is 5x positive 3y is equal to 30, this will have infinitely many solutions. For every x there will be a corresponding y, and if you take that x and the y and you substitute it in this equation, you get left hand side is equal to right hand side. So that would mean x and y are solutions to the given equation. Now next important question, this is a different form of question. When will the pair of linear equations, or 2 equations are there, have unique solutions? Unique solution means you will only get a solution when you solve that system. So I'm going to write it here. Okay, answer. Let a1x positive b1y positive c1 is equal to 0 and a2x positive b2y positive c2 is equal to 0 be two linear equations. Upon solving, the equations will produce unique solutions. So you will not be able to find anything else other than the solution that you have worked out. So let me write that. The equations will produce unique solutions if and only if. IFF stands for if and only if. If and only if M1 is not equal to M2. So what is M1? M1 is slope of, if I were to take this as 1 and take this as 2, it's a slope of 1, and M2 is slope of equation 2. So this is the requirement. Now no solution, this is the next case. Let me write that down. No solution. So when will this situation be possible? Two linear equations will produce or will have no solutions. Will have no solutions if they have equal slope, right? So what it means by that? Okay, let me give you the example. Let a1x positive b1y positive c1 is equal to 0 and a2x positive b2y positive c2 is equal to 0 be the pair of linear equations with slope m1 and m2 such that if m1 equals m2, this implies the pairs or pair of linear equations will not have a solution. So to check it out, first you need to find the slope. Once the slope tends to be equal, then you can outrightly state that the pair of linear equations will not have a solution. Why? Because m1 is equal to m2. So that is how you need to justify. Okay, so let us work some questions. Okay, let us do this question. Solve 2x positive 5y is equal to 20 followed by 3x positive 6y is equal to 12. So solution, I'm going to write this down. Consider 2x positive 5y is equal to 20. So what I'm going to do is I'm going to find the slope. Find the slope. So what is the slope? You need to write the system as y is equal, when I say system, I'm talking about the equation, right? Y is equal to mx plus c. This is how we write the given equation, and then m will be the slope. So in this case I'm going to write it as 5y is equal to 20 negative 2x. So y is equal to 2 over 5 times x positive 20 divided by 5 will give me 4. Therefore slope m1 is equal to negative 2 over 3. Consider next, this can be taken as step 2. This can be taken as step 1. Now consider step 2. This system 3x positive 6y is equal to 12. I'm going to rewrite this as 6y is equal to 12 negative 3x. So therefore y will be equal to negative 3 over 6 times x positive 12 over 6. So this is going to be negative 1 over 2 times x positive 2. This is what we have got. So what is the slope here? So therefore m2 is equal to negative 1 over 3. Now since m1 is not equal to m2, this would mean the pair of linear equations will produce unique solution. So that would mean there would be a unique x. What is the meaning of this? This means there will be a unique x and y at which the two lines intersect. So that is what our main idea is. Two lines intersect. So that is what we are looking for. When we're talking about solving these things, say for example we got a line here, right? And we got another line over here. So we are looking for this point. This point is what is my x and y. In other words, if there is an intersection of line 1 and line 2 at this particular point, say some point capital A, and that coordinate is x and y, you will not be able to find another x and y. Not possible. So there will be just one x and y at which the line L1 and L2 will form the intersection or will have an intersection. So this is a very important concept. So solving algebraically. So now this is more like a justification for unique solution or a check for a unique solution. Now we need to solve it, right? We need to solve and find x and y. So I got 2x positive 5y is equal to 20, and I've got 3x positive 6y is equal to 12. So what I will do, I will multiply this by 2. So this is 1, this is 2. You multiply 1 with 3. This is going to be 6x. Okay, let me write that down here. 6x positive 15y is equal to 60. You multiply this by 2, equation 2, you multiply it with 2, so you get 6x 12y 24. Change the sign, negative, 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 strike this. This is 3y, and 10, 6, there is a 5 here, from 5 you take away 2, you get 3. Therefore y is equal to 36 divided by 3, so y is equal to 12. When y is equal to 12, you substitute it here. Put y is equal to 12 in 1. So what do you get? You get 2 times x positive 5 times 12 is equal to 20. This means 2 times x positive 60 is equal to 20. 2 times x is equal to 20 negative 60, which is equal to negative 40. So x is equal to negative 20, right? So therefore L1, two lines, L2 intersects at negative 20 comma 12, and this is a unique or an unique solution. As I mentioned to you, you will not have any other intersection apart from this point x and y, right? So that is a very important concept I have explained to you here. And not only that, this particular concept which I've just explained to you will be occurring and reoccurring all through your higher education. Specifically when it comes to solving problems or solving application problems or even solving complicated systems, you will have to check for the intersections. Welcome students. In this class we will learn in detail as to how exactly we can obtain the solution for the given pair of linear equation. So remember, the key word is pair. Now why do I stress this? Because remember, if you are just given a linear equation, if given a linear equation in two variables, then the equation will have infinite number of solutions. Have that in mind, because suppose, imagine you have a linear equation in two variables, say 3x positive 2y is equal to some 7. Now if you were to draw the graph for this function, let us assume the function is of this fashion. Say when x is equal to 0, y is, say, instead of taking it as 7, let me take it as 8, so that I will have a complete number. When x is equal to 0, y is going to be 4. This is the point, 4. And when y is equal to 0, x is going to be 2.6, right? If this point is 1 and this point is 2, 2.6 would be somewhere over here. Let me just take this as 2.6 and this point is 4. So if I were to connect this, right, any point on this line is a solution to this equation. Have that in mind. So if that be the situation, then this line 3x positive 2y is equal to 8 will have infinite number of solutions. So that's the key note that we will have to record in our minds. Now, having mentioned that, the main point here is how to obtain the solution for the given pair of linear equations. Now, these are the techniques that are applicable, so you can choose one of them. Now the first technique is through graphical way. I will explain to you how exactly we can use this method. This is called as graphical method. The second technique is using algebraic method. Now under algebraic method we have what is called a substitution method, and method B is through elimination, and C is cross product. METHD is a short form or short way to write it. So these are the possible techniques we can apply in solving the given pair of linear equations. So having mentioned that, let me give you a question. I'm going to give you this question and I will be applying graphical method. So I'm going to use this. Tom goes to a cake shop and buys 3 muffins and 2 say biscuits, chocolate biscuits, CHOC. Width is 80 rupees that he asks. While Melody buys 4 muffins and 3 choco biscuits, BISCUITS, choco biscuits, with her 110 rupees that she asks. Now the question is, find the cost of the muffins and the chocolate biscuits. Now I hope you all know, right? Muffins will be looking something of this fashion. It will be dark in color with some nuts, and chocolate biscuits, they will be little bit like this, and they will have nuts and also some cookie dough, and it will be a delicious treat. Suppose you are having this with some good milk or milkshake, something of that nature. Okay, so clearly you have a good problem, and I'm going to apply graphical method to solve the question. So Tom goes to the shop, he gets 3 muffins and 2 chocolate biscuits, 3 and 2, and Melody goes to the shop, she gets 4 muffins and 3 chocolate biscuits with the cost. Melody has got 110 rupees, Tom has got 80 rupees. So we will have to design a system. Let's move to the next page and let's do that. So this is the equation for Tom. So I'm starting, let x be the cost of a muffin and y be the cost of a biscuit. Then the equation connected with Tom is, he buys 3 muffins, 3 times x, and 2 biscuits with his 80 rupees. So I take this as 1. Now Melody buys 4 biscuits. So this is the equation for Melody. 4 muffins and 3 biscuits with her 110 rupees, right? Now graphically we will have to get the solution through graphical way or graphical method. METHD stands for short form for method. We will solve this question. The much needed point you will have to pose here is, how are we going to do that? Simple. So I've taken this as 1, I'm taking this as 2. What we need to do is, our objective, let me state the objective. Our objective is to find the point of intersection of equation 1 and equation 2. That's all we need to do. If we are able to get that, and that would represent the solution. That's all we need to do, and that would represent the solution. So the point of intersection will represent the solution. So that's an important point you will have to know. So what we will do is, I will start by, as I mentioned to you, I will consider 1, and 1 can be rewritten as in terms of y. So I'm going to write this as 2y is equal to 80 negative 3x. Therefore y is equal to, I'm dividing by 2, so 40. In fact you can simply write that as 80 negative 3x divided by 2. You don't have to divide by 2. So let us draw the graph. So this is going to be, you can take values for x, and then this would be the value for y. I'm going to substitute it here. So what are we going to take? Now if I were to take x is equal to 0, then I get 80 over 2, that's going to be 40, I get 1 point. So if I were to take x is equal to 10, that's 30, so I will get 50 divided by 2, which is equal to 25. So I will get, when x is equal to 10, I will get 25. When x is equal to 20, 10. When x is equal to 30, that's 90, so that goes overboard. So we don't have to take that much bigger number. Now if you wish, you can get values for minus 10. If you were to take minus 10, this would become negative or negative positive. So 3 times 10, 30. 30 and 110. 110 divided by 2 is 5 and 5. This is going to be 55. And if you were to take 20 60, 140, that's going to be 70. That's enough. So students, I have written these coordinates exclusively. So now I will draw these two graphs. I will unify them. So this is x-axis, this is y-axis, this is 0. So let's take this as 10 units, 20, 30, 40, 50, 60, 70, 80, 90, 100, negative 10, negative 20, negative 30, negative 40, negative 50, negative 60, so on and so forth. This is 0. And this is going to be 10, 20, 30, 40, and so on and so forth. 40, 50, 60. I'm going to plot the first point. So 0, 0, 40. 1, 2, 3, 4. This is going to be the point. So this is done. 0, 40 is done. Next is 10, 25. 10, 25. This is 20. 25 is over here. This is finished. Then 20, 10. 20 and 10. This is going to be the point, 20 and 10. So let me just connect these points. If you are looking for x intersection, all you need to do is take 3x positive 2y is equal to 80 and put y is equal to 0. So you get 2x is equal to 80. 3x is equal to 80 and x is equal to 80 divided by 3. Just drawing this, it's a rough figure. Now let me plot the other points. 20, 10. Then 20, 10. You see that this is what is required. 20, 10. When x is 20, y is 10. There is a point there. Then 50, negative 30. 50, negative 30. This is 10, 20 and 30. Negative 30, that's going to be over here. Approximately that's going to be over here. And then I got this. Then 0 and 36. 0 and 36 would be over here. Somewhere over here. Right? So this would be the point. So if I were to hit it, the graph will be something of this fashion. This is going to be the line and this is the point of intersection. And of course, this graph is not the absolute representation of what the equation 3x positive 2y equal to 80 and 4x positive 3y equal to 110 would have given us. But it doesn't matter. What matters is the points that we see here. When x is 20, y is 10. When x is 20, y is 10. So this is what we are looking for. So that's the idea I want to present it to you. So therefore the solution is what? The solution is when x is equal to 20, y is equal to 10. So we are looking for the prices, right? So this would mean the price or the cost of one muffin is equal to 20 rupees and the cost of one biscuit is equal to 10 rupees. So clearly you can check it out. It says 3x positive 2y is equal to 80. So 3 times x is equal to 20 positive 2 times y is equal to 10 should give me 80. This is the amount that Tom is spending. So this is 60 positive 20 is equal to 80. So 80 is equal to 80. So left hand side is equal to right hand side. So this is how you will have to approach solving pairs of linear equation using graphical method. Of course, I will be doing other questions so that you can achieve a greater level of familiarity with regard to solving linear systems using graphical method. Students, let's do the first question. Let me read the question for you. Aftab tells his daughter, 7 years ago I was 7 times as old as you were then, and also 3 years from now I shall be 3 times as old as you will be. Isn't this interesting? Represent this situation algebraically as well as graphically. It's a very simple question. Foremost, you need to start off like this. Let Aftab's age presently, or present age, be equal to x. Let his daughter's age presently be equal to y. So Aftab is telling 7 years ago, this is how you need to write. 7 years ago, you take away 7, I was 7 times old as you were. So when you take away 7 from Aftab's age, you should also take away 7 from his daughter's age, and then you multiply it with 7. This is one system, right? So if you were to simplify this, what would you get? You get x negative 7 is equal to 7y negative 7 times 7 is 49, and then you can write this as x negative 7y is equal to 7 positive of negative 49, so that's going to be negative 42. So x negative 7y is equal to 42, or you can write this as x negative 7y positive 42 is equal to 0. So this is one system. You can either use this system or you can either use this system to graph. So this is one equation. Now he also tells something more, right? So this is the second part, also part 2. This is part 1. So what does it say? It says also 3 years from now on, 3 years from now. So we have taken x to be his present age, right? So 3 years means it is in the future. So x positive 3 is equal to, you need to do the same thing for y also. It's not enough that you just add for x. So y also should be added. So x positive 3 is equal to y positive 3, but this is not the system. It says 3 years later, my age is going to be 3 times your age 3 years later. So this is the system. So equate this, x positive 3 is equal to 3 times y positive 9. This is rewritten as x negative 3y is equal to 9 negative 3, which means x negative 3y is equal to 6. Either you can use this system or you can write it as x negative 3y negative 6 is equal to 0. So if they are asking you to solve by algebraic technique, you can either use this equation or this equation. We are interested in graph, so we need to plot the graph. So let me do that. Whenever you are drawing the graph, you need to have a representation for y. So in that case, what we can do, we need to push this to the other end. So let me just do that. This is for graphical way. So as far as the equation, algebraic equation is concerned, 1 and 2 are sufficient for us to get the score. But for graphical way, we need to do some slight tables and fit in the data. So you can state that from 1 we get, what do you get from 1? This can be rewritten as, I'm going to write it as x positive 42. I take 7y with a negative sign to the other side, positive 7y. So therefore y is going to be x positive 42 divided by 7. This is what we have got. Now choose the value for x suitably. Now why do I say suitably? Because we need to make sure that we are able to divide it by 7. Now when x is equal to 0, 7 times 6 is 42, right? So 0 means this is 6, and I can take x is equal to 7. because 7 added with 42 will give me 49. 49 7 7s are 49. So when x is equal to 7, I'm getting 49, and that divided by 7 will give me 7 here. It's a beautiful number. So I've taken 7. Can I take 14? Oh, that's lovely. If I were to take x is equal to 14, I'm going to get 56. So 56 means this is going to be 8. So that's a beautiful quantity we are getting. Now we need to go to the left hand side. If I were to take x is equal to negative 42, this is going to become 0. So if x is equal to negative 42, y is going to be equal to 0. We need that value also. These values alone are enough for me, right? So let me draw the graph. Y value seems to be really large here, negative 42. So this is the axis, x-axis, and y-axis. So this is x, this is y. I start with 0 and 7, 14 and 28, so on and so forth. So let me take these values as 1, 2, 3, 4, 5, 6, 7 and 8. So when x is equal to 0, I am hitting here 6. So 0, 1, 2, 3, 4, 5, 6. So this will be a point. When x is equal to 7, it's going to be 7. I'm hitting here. When x is equal to 14, it's going to be 8. So this will be 8 here, right? I'm not specified, but I'm just giving you a representation. So now coming to 42. So if I were to take this one as 7, 7, 1, 2, 3, 4, 5, 6, 6 sevens are 42. This will be minus 42. When x is equal to minus 42, y is equal to 0. So this will be the point. So if you were to connect this point, the graph would be hitting like this. Okay? It's an arrow there. So this is the graph for the first system. Now we can also simultaneously draw the graph for the second system. So let us do that. So the second system we have got is, it's over here. So consider, or you can simply state from 2, what you got? You got x negative 3y negative 6 is equal to 0. I'm going to rewrite this by moving this negative 3y to the other side. So x negative 6 is equal to 3y. Therefore y is equal to x negative 6 divided by 3. This is what you got. Now you can draw a box like this, and then you can put in the values for x and y. So this point is x, this point is y. So what I will do, I will take x is equal to 0. If I were to take x is equal to 0, you can clearly see that I will get negative 2. Negative 6 divided by 3 would give me negative 2. And then I would want to take x is equal to 9. Why do I take x is equal to 9? Because 9 negative 6 would give me 3. I will get a 1 over there. Now if I were to take 12, if I were to take x is equal to 12, watch here, 12 negative 6 would give me 6. 6 divided by 3 would give me 2. So I'm taking 12 there, and this is going to give me 2. Now if you want, you can include this point, or else you want to jump in cases of 9, and then 9 2s are 18, 9 3s are 27. If I were to take x is equal to 27, so this x is equal to 27, it will give me 21. 21 divided by 3 will give me 7. So instead of taking 12, you can take it as x is equal to 18, and still you will get a good value. Now if I were to take x is equal to 6, if I were to take x is equal to 6, I will get 0. So these points are sufficient enough for me to plot. So go first for x is equal to 0. When x is equal to 0, you're getting negative 2. So it's negative 1, negative 2. So this is going to be the point, right? So you can actually plot this, right? So this is negative 1, negative 2. And let's just have it as it is. Now the next point is when x is equal to 9, I get 1. X is equal to 9. If this point is 7 and this point is 9, I'm getting 1. So let me plot this point. and when x is equal to 12, you can take it as 12, I get 2. So that's fine. That's also comes in handy. When x is equal to 18, if I were to take x is equal to 18, I get 4. So 18 would be somewhere over here. I get 1, 2, 3, 4. So I think these points are sufficient enough. 27, 7, it still goes on further. So I don't need those points. Now, if I were to draw the line, draw the intersection, my intersection would be something like this. Okay, it cuts here, right? Probably you can draw a larger circle, right? Of course, on the graph sheet you will be able to get a better plotting, since I'm not using a graphing sheet. So this point is going to be 0, -2, and you can write the equation. So this is going to be x -3y. You can write it equal to 6. You can write it like this. And this one you can write it on the system itself, on the line itself, as x -7y is equal to -42. Depending on where you will want to write it, you can either write it like this or write it like this. So that is the solution to the question, students. We'll move on to the next one. Students, let's do this question number 2, exercise 3.1. Now let me read this question. The coach of a cricket team buys 3 bats and 6 balls. 6 balls for 3,900 rupees, and later on he buys another bat, that's 1 bat, and 3 more balls of the same kind for 1,300 rupees. Now we are expected to represent this by means of a graph, is also referred to as geometrically, and also by algebraically. Now what we can do is, let us start off like this. So this is the solution. So I'm going to say that let the cost of a bat be equal to x, and next is let the cost of a ball be equal to y. So if I were to take it as 1 and 2, I'm going to use the space here. From 1, what do you have? 3 times x positive 6 times y is equal to 3,900, and then from 2, what do you have? You got x positive 3 times y is equal to 1,300. So these are the two systems that we have got. So the question wants us to represent this algebraically, and this is the solution for that. Now it also wants us to represent this by means of a graph. So let me take this as 3, and let me take this as 4. From 3 we get, write it in terms of x for y. So 6y is equal to 3,900 negative 3 times x. So therefore y is going to be 3,900 negative 3x divided by 6. Now you can either simplify it or you can just retain it as it is. Now let us draw the tabular column. So it's better to use scale instead of freehand, because sometimes freehand's tabular column looks a little bit funny. So that's the reason I'm using this. Okay, let me take x and let me take y. Now if I were to take x to be equal to 0, what do I get? I get 3900 divided by 6. And let me see, what do I get? 6 times 6 is 36. I get 3. 6 times 5 is 30, and a 0, you add a 0. So when x is equal to 0, you get 650. Now always choose a x such that this quantity is a whole number. Now if I were to take x is equal to say 100, this is going to give me 3900 minus 300, that's going to be 3600, and in that case it's going to be 3600 divided by 600, which is divided by 6, which is going to be 600. So when x is equal to 100, this is going to give me 600. Similarly, I'm going to take x to be equal to 300, and that would give me 500, right? So the next value would be x being equal to 700. If I were to take 700, 7 times 3 is 21. So from 39 you take 21, you get 8 and a 1. So that would mean you get 300 here. So this is the tabular column for the first system. Now we will have to use the second system. So I'm going to say from 4, you got x positive 3y is equal to 1300. You move the x to the other side. So 3y is equal to 1300 negative x. Therefore y is equal to 1300 negative x divided by 3. This is what you've got. So let's draw the tabular column. So I'm going to take x here and y, and we can choose the values. If I were to take it as 0, this 1300 divided by 3, that wouldn't give me a complete number, right? I'm looking for a whole number, and in other words, I don't want to take it as 0. So let me take x to be equal to 100. If I were to take x to be as 100, I would get 1200 divided by 3. So that's going to be 3 times 4 is 12. And that would give me 400 over here. 3 zeros are 0, 3 zeros are 0, and 3 times 4 is 12, and that's fine. So this is going to be 400. 300, if I were to take 300, again the quantity is not going to be a whole number. So I want to drop that 300, and I would take x to be as 400. If I were to take x to be as 400, then this would give me 900. So I will have 900 divided by 3, that's going to be 300. Now let me take x to be as 700. So when I take x to be as 700, this would give me 1300 minus 700, that's going to be 600. So 600 divided by 3, that's going to give me 200. So we are not able to get any intersection at all. Let's see how the graph is going to be looking like. Now let me write down the coordinates for the first system, and that would be 300, 500, 100, 600, 700, 300. And for the second equation, it's 400, 300, 100, 400, and 700, 200. Now we need to find the x-intercept. That is very important. So x-intercept for the first one, the system, the equation for the first one is 3 times x positive 6y is equal to 3900. To get the x-intercept, we substitute y is equal to 0. So put y is equal to 0. So that would mean we get 3x is equal to 3900. So x is equal to 1300. So this is the x-intercept for the first system. Now we also need to find the x-intercept for the second system. And the second system is x positive 3y is equal to 1300. You put y is equal to 0, you get x is equal to 1300. So the x-intercept for both the lines happens to be 1300. So now you can plot the points by graphical way. I'm just going to give you a demonstration in this fashion. Since you know the points, it's not going to be difficult. So this is x-axis, this is y-axis. X is, in fact, there is one more point. When x is 0 for this first equation, we add 650. So x is equal to 0. If you were to take this as 1, 2, 3, 4, 5, 6. When I say 1, 2, 3, 4, 5, 6, I mean 100, 200, 300, 400, 500 and 600. So 650 would be somewhere over here, right, when x is equal to 0. Now 300, right, if this is 1, 2, 3 and 5, 1, 2, 3, 4, 5. So this would be the point. And 300. So you got a point there. Then 100, 600, 100, 600, 1, 2, 3, 4, 5, 6, and 600 is over here. And 700 and 300, 3, 4, 5, 6, 700 and 300. 300 is over here and 700. So you can plot these points and then name them, right? Name these points. Now what I am going to do is I'm going to connect these points. I'm going to make a connection and I have to ensure that the intersecting lines are hitting at 1300. That's important. So before I could do that, let me plot the points 400 and 300. So 1, 2, 3, 4, 400 and 300. 300 is over here. So I got a point there, and then 100 and 400. 100 and 400 is over here, and 700 and 200. 700 and 200, that is over here. This is 700 and 200 is over here. Now what we need to do is we need to ensure that both these points are hitting at the same point. So let me draw it like this. So there is a hit there, and this hit should be the same for both these graphs. Okay, so make sure that they are hitting at the same point. So and you can name this point as 1300, 0. That's the intersection point. So this graph is going to be x positive 3y is equal to 1300. This graph is going to be 3x positive 6y is equal to 3900. Now that would be the end of this particular question. Probably you can give an arrow here. You don't have to stretch it and hit it on the y-axis. You can just simply leave it like this, because we have not extracted the y-intercept except for the first point. Second point, it's not a whole number. So that is the solution for this question. We'll move on to the next one. Now this is another important concept with regard to pair of linear equations that you will have to know. Now the first important concept is, if the pair of linear equations has no solutions, then we call such a pair of linear equations to be as, when I write ILE, it means linear equation. Then we call such a pair of linear equations as inconsistent. inconsistent pair of linear equation. Now I will give you a technique how exactly we can decide outrightly whether a given linear system is consistent or inconsistent, or the third alternative or the third option is dependent. So this is the first point. The second point is, if the pair of linear equation, so when we talk about linear equation, we are talking about linear equation in two variables. So remember that we are only dealing with linear equations in two variables. Now if the pair of linear equation in two variables has a solution, then we call such a pair of linear equations as consistent pair of linear equation. Number 3, on the other end, if the pair of linear equation in two variables as infinitely, infinitely many distinct solution, then we call such a pair of linear equations as dependent pair of linear equations in two variables. So these are the three important differentiations that you will have to know: inconsistent, consistent, and dependent. Now, how are we going to find them out? That's an important part of problem solving. Okay, so let me give you this all important technique. The first technique, right? So this is a tip, or you can call it as a technique. Let us consider a1x positive b1y is equal to, say, c1, and a2x positive b2y is equal to c2. Two systems are there. Now first and foremost thing what you need to do is you find out what is a1 over a2, and then you find out b1 over b2, then you find out c1 over c2. If a1 over a2, this is the requirement, is not equal to b1 over b2, then the graph will definitely intersect. The graph will intersect, and that will mean there will only be one unique solution. Once the intersection takes place, then that is the only point the graph will intersect. So I have a graph that's coming down like this, then I have another graph that's going up like this, and they are intersecting here. So this will be the only point. There will not going to be any other point of intersection after this. It's not possible. Simple as that. So what you need to do is you need to find this, and this. Of course, this is just for the sake of being consistency. In other words, this has got no impact for values of situations like this. The moment you find out that A1 over A2 is not equal to B1 over B2, then you can outrightly state that the graph is going to be intersecting and that they will going to be having just one unique solution. So that's the conclusion for that. Now point number 2. If you find out A1 over A2 is equal to B1 over B2, so this is why I placed C1 over C2 here, because we will be using C1 over C2 over here. And if this quantity is equal to C1 over C2, then the graph will be coincident lines. That means they will be actually meeting one another, and there will be infinitely many solutions. So this is the second case. Now the third case is that if A1 over A2 is equal to B1 over B2 and it is not equal to C1 over C2, then the graphs will be parallel lines, and there will be no solution. Right, so these are the three cases. Now I'm going to give you an example so that you can better understand and apply this concept. So let us do this question. I'm going to be placing this question over here and the solution also, so that you can follow the law along with the working. Now we are given an example. So this is an example. Say x negative 2y is equal to 0 and 3x positive 4y negative 20 is equal to 0. So first foremost thing what you need to do, you need to find out A1, A2. So from here, what is A1? A1 is equal to 1, B1 is equal to negative 2, and A2 is equal to 3, and B2 is equal to 4, and you got C2 here. C2 is equal to negative 20. Of course C1 is equal to 0 here, right? There is no C1 here. So what is A1 over A2? A1 over A2 is 1 over 3, and I'm placing equal to sign. A1 over A2 is 1 over 3. I'm just placing equal to sign, and next after I got the value for B1 over B2, then I'll make the decision. So B1 is negative 2 divided by 4. That's going to be 1 over 2. Now the question is A1 over A2 equal to B1 over B2? Are they equal? No, they're not equal. So in this case, the graphs will intersect and they will have a unique solution. So conclusion, you can state the conclusion like this. Conclusion, if they are asking you to conclude, the pair of linear equation, or you can simply say the graphs will intersect, and there is just a unique solution. SOLUTION. You can either write a unique solution or an unique solution. It doesn't matter, as long as you place the keyword unique. So that is the example for the first one. Now let me just give you another example for indicating the second one. Say for example, you got a system like this. I'm going to use this part of the page here. So 2x positive 3y negative 9 is equal to 0. And then over here 4x positive 6y negative 18 is equal to 0. Now when you move, this is going to be 9 and 18, right? It's 9 and 18. So you can also place C1 on this side and C2 on this side. Now find out what is A1 over A2. Can you find out what A1 over A2? I'm going to write it down here. A1 over A2 is 2 divided by 4, and B1 over B2 is 3 divided by 6, and C1 over C2 is 9 divided by 18. Now are all they equal? 2 divided by 4 is 1 over 2, 3 divided by 6 is 1 over 2, 9 divided by 18 is 1 over 2. You see that? All these ratios are equal. So that would mean the graphs will be coincident and they will have infinite many solutions. So this is the conclusion that you will have to state. Okay, finally let me give you this illustration. So x positive 2y negative 4 is equal to 0. 2x positive 4y negative 12 is equal to 0. So what is A1 over A2? That's 1 over 2. And what is B1 over B2? That's also 1 over 2. 2 over 4. C1 over C2, 4 over 12. 4 over 12 is 1 over 3, right? This is 1 over 2, 1 over 2. These two are equal, but this isn't equal. So this will be the conclusion. The graphs will be parallel lines and there will be no solution. So students, that is the conclusion for this particular concept. We will again meet for another new concept. Thank you. Welcome students. In this class we will look into this specific method, elimination method. Now imagine you are being given this question. You are asked to solve 3x positive y is equal to 10, negative 4x negative 2y is equal to 2. So you are being given two equations. Let me state that. So we are given a pair of linear equations. Now let me name them as equation 1, equation 2. Now the foremost, what we will have to do is we will have to choose one of these variables to be eliminated. Usually we will eliminate x. So for that, ensure that the coefficient of x that you see in this first equation is the same as the coefficient of this x that you see in the second equation. And that is achieved in the following manner. Now clearly you can see this is 3. If I were to multiply 1 by 4, I will get 12. And if I were to multiply the second equation, which you see here, by 3, I would get negative 12. So the idea is to have the coefficients to be same. So what I will do is I will multiply equation 1 by negative 4, and that would give me negative 12x, positive times negative is going to be negative 4 times y is equal to negative 40. Now equation 2, you multiply it by 3, because if you were to do that you will get clearly negative 12x, right? You don't have to place any signs here. Followed by 3 multiplied with negative 2 would give you negative 6y. 3 multiplied with 2 would give you 6. That's it. So as I mentioned to you, the idea is to have the coefficients of x to be same to the coefficient of x that we see over here. Now since we have multiplied equation 1 with negative 4, now we have a new equation and I will name it as 3 and 4. Now what I will do is I will add them both. Now since I have a negative sign, always change the sign. Negative becomes positive, negative becomes positive. There is a positive sign here. Positive means negative. So clearly you have a negative 12x that has to be added with positive 12x. So these two quantities can be cancelled. You have negative 4y added with positive 6y, and that is going to be giving you 2y. You got negative 40 added with negative 6, that's going to be negative 46. So this is what you have got. Now clearly you can easily extract the value of y. So this would mean y is equal to negative 46 divided by 2. 2 divides here 23 times. So therefore the value of y is negative 23. Make sure to have the sign. Now what I will do is I will substituting y is equal to negative 23 in 1. You can either substitute it in 1 or in 2. So that would mean I now have 3 times x positive, because the sign is positive, open a parenthesis, place the negative quantity and equate it to 10. So this is equal to 3 times x, negative 23 is equal to 10. So this would mean 3 times x, move this 23 with the negative sign to the right. That would give you positive 23. 23 added with 10 would give you 33. So therefore you got 3x is equal to 33, and x would be 33 divided by 3, which is equal to 11. Now it is better you perform the check. After you have obtained the value of x and y, you perform the check. So how do you do the check? You substitute the value of x and y in either in 1 or in 2. Now let me choose 2 just for the sake of being a little bit different. So what I will do is I'll take the value of x, substitute it here. I'll take the value of y and I'll substitute it here. I need to get 2 here. Negative 4 times 11 would give you negative 44. Negative positive. 2 times 23 would give me 46, which is equal to 2. This 2 is actually present on the equation side, on the right hand side. 46 added with 44 would give you positive 2, which is equal to 2. So this would mean the left hand side is equal to right hand side. So make sure that you state this explicitly. Left hand side is equal to right hand side, and underline this word check. So this would convey to the examiner that you have meticulously executed the solution for this particular system. So we'll move on to the next question. Now this is the next method, students. This is called as cross product method. Sometimes it is also referred to as Cartesian product. Now suppose you are given 2 equations. Let us consider a1x positive b1y positive c1 is equal to 0, and a2x positive b2y positive c2 is equal to 0. Now we are expected, or we are asked to find the value of x, find the value of y. So the formula is you place x here and then just leave this particular column out. Don't take this column into consideration. Now what you got to do, you got to take c2 and multiply it with the coefficient of y. In this case it's b1. So c2 with b1, you can write it like this, c2 times b1, and you need to multiply b2 with c1. Now when you are multiplying a quantity from the left hand side, make sure to place a minus sign and then place b2 times c1, and then you place a equal to sign and then place y. Now what you got to do is you have to ignore this column and take in the values. So if you were to ignore this column, I have c2 and a1, so multiply c2 with a1, multiply a2 with c1. When you're multiplying a quantity from the left hand side, you have to place a negative sign and you can multiply it a2 times c1. So this is the value for the component y. And next you place an equal to sign and place 1. Now you have to ignore this particular column c1 and c2, and then multiply b2 with a1. So b2 with a1, and you have to multiply a2 with b1. So when you're multiplying from the left, you place a negative sign and then you multiply a2 times b1. So this is the all important technique using cross product method. Now you might be asking, how are we going to apply this? I'm going to apply this method for the same question and extract the solution. So this is given 3 times x positive y is equal to 10 and negative 4x negative 2y is equal to 2. So what I wish to do is I would like to move all the constant to the left. Consider, I'm going to write it in this fashion, consider the following equations. So 3x positive y negative 10 is equal to 0. I am taking this as 1, and you got negative 4x negative 2y negative 2 is equal to 0. I am taking it as 2. So from here, applying cross product technique, we get, so place the x divided by, leave this column, whatever you got, negative 2 times 1, coefficient of y is 1, that's going to be, probably I'll state it here, negative 2 times 1, followed by, if you are multiplying from the left, you place a negative sign, and then negative 2 times negative 10. If you want, you can place it, negative 2 times negative 10 is equal to y over, leave this column, it's going to be negative 2 times 3. When you're multiplying from the left, you place a negative sign, and then negative 4 times negative 10 is equal to 1 over, leave this column, so negative 2 times 3, negative 2 times 3, when you're multiplying from the left, place a negative sign, negative 4 times 1. So what I wish to do is, I would like to compare this with this, because I need to get the value for x, right? That's my objective. So x over negative 2, let me use this rough column, negative 2, negative negative positive, positive times negative will give you negative, 2 times 10 is going to be 20, so this is going to be negative 22 is equal to 1 over negative 2 times 3, that's going to be negative 6, negative negative positive, 4 times 1 is going to be 4. So you have a negative 2 here, right? So place a negative 2, and you got your, since I'm equating this with this, you got 2 negatives that would be dropped, and you have a positive sign here, so moving this to the other side, so therefore x is equal to 22 over 2, which means x is equal to 11, and you can write that down. Let me show that to you. So also you can state that y over negative 2 times 3, I'm writing it down here, negative 6, and negative negative positive, positive times negative gives me negative, 4 times 10 is 40, so this is going to be negative 46. So negative 46 is equal to, now there is one important concept you will have to remember. Whenever you are dealing with the second component, you have to carry a negative sign in front, because that is the way we order the signs. So we start with positive and a negative and a positive. So when we were dealing with the first and the last term, we did not have any issue, but when we are dealing with the second and the third term, we need to carry a negative sign. So having said that, you should also place that in the formula. So I would place that negative sign over here. That is critical. Probably I will work out another question so that you can have a better understanding. So this is going to be a negative sign here, which is equal to, this is already equal to negative 1 over 2, because we found that out in the previous case. So this is negative 1 over 2. So we got a negative sign, and that would be dropped, and this would mean you got y is equal to negative 46, push it there, you divide it by 2, so 2 divides 46 23 times, therefore the value of y is negative 23. So you can clearly see that this is the exact value that we got here. You see that? Negative 23. So that is how we apply cross product method to extract the values of the variables x and y. Now let me do this quick question. Solve using, this is how they will give. Solve using cross product method. And the system is 2x positive 3y is then followed by negative 4 is equal to 0, and 3x positive 2y negative 11 is equal to 0. So this is in the expected form. Now what we can do is, by cross product, you can simply state that we get, so what do you get? You can place x like that, divided by, leave this column, multiply negative 11 with 3. When you operate from the left hand side, you carry a negative sign, and then 2 multiplied with negative 4 is equal to, when you come to the second term, you place a negative sign and you place y, divided by, you leave this column, negative 11 multiplied with 2, and when we are taking it from the left side, you carry a negative sign, so place the negative sign. So 3 multiplied with negative 4, so that's what you got. This is equal to constant divided by, leave this column, and 2 multiplied with 2. When you are operating from the left side, take a negative sign, 3 multiplied with 3. This is what you got. So now what I will do, I will take the first term with the last term. So you got x divided by negative 11 times 3 gives you negative 33. Negative times negative is positive, 2 times 4 is 8, is equal to 1 over 2 into 2 is 4. 4 negative, 3 times 3 is 9. Now this is rewritten as negative 33 added with 8. That's going to be x over 25 with the negative sign. 4 added with negative 9. That's going to be negative 5. So therefore x is equal to 25 divided by 5 with the negative sign, they would become positive. Therefore x is equal to 5 divides 25 5 times. So you can just substitute it there. Now having got the value of x, you can either substitute it over here to get the value of y, but I just wanted to use this system. So it's negative of y divided by negative 11 times 2, negative 22, negative positive, 4 times 3 is 12, is equal to 1 over this quantity we have already evaluated it. That's negative 1 over 5. So these two negatives will be dropped, they will become positive, and so you got y divided by negative 22 added up with positive 12. That's going to give me a negative 10 is equal to 1 over 5, and therefore y is equal to negative 10 divided by 5. 5 divides 10 2 times, so our value of y is negative 2. So now what we need to do is we need to carry the check. I'm going to apply the check here. Check. So we will substitute the values of x and y in equation 1. So I can take this as 1 and take this as 2. So what happens if I were to do that from 1? I've got 2 times x value is 5, substitute this, positive 3 times y value is negative 2. I should get the right hand side. Right hand side is actually 4 moves to the right hand side, I get positive 4. So 2 times 5 is 10, 3 times 2 is 6 with a negative sign is equal to 4. 10 with negative 6 will give me 4. 4 is equal to 4, which means my left hand side, you need to state that left hand side is equal to right hand side. Right? So that would mean our solution set, this means our solution set is what? X is equal to 5 and y is equal to negative 2. So that's the answer for this question. Students, we got a beautiful question. We are expected to solve this system. We've been given 2 over x positive 3 over y is equal to 13, and we have got 5 over x negative 4 over y is equal to negative 2. This is 1 and equation 2. Now what I will do is I will just make the following substitution. Let a be equal to 1 over x and bb is equal to 1 over y. Therefore 1 can be rewritten as 2 times a positive 3 times b is equal to 13, and 2 can be written as 5 times a negative 4 times b is equal to negative 2. Now I would like to bring the quantities towards the left hand side. So that would mean, this means this is going to be 2 times a positive 3 times b negative 13 is equal to 0, and 5 times a negative 4 times b positive 2 is equal to 0. I take this as equation 3. I take this as equation 4. So we are going to be applying cross product, and by applying cross product, this is going to be a over, leave this column 2 times 3. When you are moving towards from the left hand side is going to be a negative sign that's going to be walking along, followed by negative 4 times negative 13, negative 4 negative 13 is equal to, when you are moving to the second term, place a negative sign and b divided by, leave this column 2 times of 2, you take a negative sign when we are moving from the left side, so it's going to be 5 times of negative 13. This is equal to, constant is 1 divided by, leave this column negative 4 times 2, when you're moving towards the left, from the left it's going to be a negative sign there, so it's going to be 5 times of 3. So this can be rewritten with the following connectivities. I'm going to connect, or in other words compare a with the last term. So this is equal to a over 3 times or 2 times 3 is 6, negative negative positive, positive times negative is going to be negative, 4 times 3 is 12, 4 ones are 4 is 52. I'm connecting with the last term. It's going to be 1 over 4 times 2 is 8, there's a negative sign, negative 5 times 3 is 15. So this is going to be, from 52 you take away 6, you are going to get 46, but the sign of the greater term is negative, place that. This is equal to 1 over, now 8 negative 15. So two things have to be added, but the sign will be retained. So that's going to be negative 23 there. Now you got a negative sign, you got a negative sign. Clearly you can change them to positive. Therefore the value of a is equal to 46 divided by 23. 23 divides 46 2 times. So the value of a is equal to 2. Now a is equal to 2. Now either you can extract the value of b from here by substituting, or you can utilize this and this. So let me just further down extract the value of x. Either you can extract the value of x here, or you can extract the value of x further down. So I'm going to do it here, but a is equal to 1 over x. So this means 1 over x is equal to 2. Therefore x is equal to, you push x to the right side and bring 2 down. So x is equal to 1 over 2. So you can square block that. Now coming to the value for b, as I mentioned to you, you can either take the value of a, substitute it here, but I would like to utilize this connections. So I'm placing negative of b divided by 2 times 2 is 4, negative times negative is positive, 5 3s are 15, 1 5 are 5, 65. This is equal to, on the right hand side you get 1 over negative 23. We have found that out. So this would mean you got a negative b over, this is 4 added with 65, that's going to be 69 is equal to negative 1 over 23. These two negative signs will be dropped. So therefore b is equal to 69 divided by 23, which is 23 divides here 3 times. Therefore the value of b is equal to 3. You can just substitute it there. But b is equal to 1 over y. So this would mean 1 over y is equal to 3. Therefore y is equal to 1 over 3. Right? So you got the value of a, you got the value of b. You need to apply the check. Let us perform the check. So what do you got? You got 2 over x positive 3 over y should be equal to 13. So this would mean in place of x I substitute 1 over 2 the value of x, and in place of y I substitute 1 over 3. This has been given to be equal to 13, but we need to find out if it is so. When you flip it, you get 2 multiplied with 2. When you flip this, you get 3 multiplied with 3. This has been given to be equal to 13. 2 times 2 is 4, 3 times 3 is 9. This has been given to be equal to 13. But apparently if you see that 4 added with 9 would give you 13. On the right hand side you got a 13. So this would mean my left hand side is equal to right hand side. So this is the conclusion of this question, students. It's a beautiful question, and we'll move on to the next one. Welcome students, we are continuing our study on pairs of linear equations, and we have reached exercise 3.4. I've already done a question. Now I'll be doing question number 3. Let me write down the question. The sum of the digits of a 2-digit number is 9. Also 9 times this number is twice the number obtained by reversing the order of the digits. Find the number. Now if you have a 2-digit number, say for example 21, then this 21 is actually obtained in this following fashion. The digit that you see here, this is the leading digit. This digit is actually in the 10th place, because we are actually treating numbers with base 10. And since we are dealing with numbers with base 10, this number is considered to be in the 10th place, and this number is considered to be in the unit place. That's the way we treat. Now if you have one more number that is treated to be in the 100th place, that's the way we actually treat numbers. Now this 2 is obtained by multiplying with 10, and then this 1 is obtained by multiplying with 1. So 2 into 10 gives us 20, plus 1 into 1 gives us 1. So 20 added with 1 would give us 21. So that's the way the numbers are obtained. So if you are taking a number, say let xy be the number. In fact, I can write there as be the 2-digit number. Then from the question, WKT stands for we know that. So what do we know? From the question we know that x positive y is given to be as 9. You see that the sum of the digits of a 2-digit number. So this is a digit, this is a digit. The sum of the digits in a 2-digit number gives me 9. And it says that 9 times this number, so we are talking about the number now, is twice the number obtained by reversing the order. Also 9 times the number. Now you can either write it as the 2-digit number I have represented here, but that is not going to be helping us. So we will have to convert this into the unit place and in the 10th place. So I'm going to write x as 10 times x positive y like this. I do not know the digits, so in this case the digits are known, but in place of 2 I've got an x here. So it's going to be x times 10, positive, in place of 1 I've got y. So that's the way you write it. So 9 of 10 times x positive y is equal to, is twice the number. This is equal to twice the number obtained by reversing the digits. So in place of x you should place y, in place of y you should place x. So this is the second system. So this is the first equation, this is the second equation. So we will have to use these two equations. Now since it is an elimination, what I will do is I will actually simplify 1. See, I would say simplify 2 first. Simplify 2. We get, so what do we get? This is 90x positive 9y is equal to 20y positive 2x. I move everything to the left, so it's going to be 90x positive 9y negative 20y negative 2 times x is equal to 0. This is what I have got. So I would simplify this. 90x added with negative 2x, that's going to give me 88x, and then this is going to give me negative 11y is equal to 0. I can divide by 11, so that would give me 8x negative y is equal to 0. I will take this as 3. So now we will solve 1 and 3. So what is 1? X positive y is equal to 9, and 3 is 8x negative y is equal to 0. Now we have to use elimination method. That would mean we will have to get rid of the x or the y. So in this case I got a positive y and a negative y. This can easily be eliminated. Now you got 8x added with x, so that's going to be 9x. 9 added with 0 will give me 9. So therefore you got 9x is equal to 9. So x is equal to 9 divided by 9, which would mean x is equal to 1. So I've got x is equal to 1. Now take this x is equal to 1 and substitute it in equation 1. I'll write that down. Put x is equal to 1 in 1, we get. So what do you get? 1 positive y is equal to 9. You move this to the other side, therefore y is equal to 9 minus 1, which means y is equal to 8. Now we started with the 2-digit number. We know that the 2-digit number which we assumed is of the form x into y. So this means in place of x I've got 1, in place of y I got 18. So this means 18 is our 2-digit number. So that is the solution, and that is a good place for us to stop. And if in case you wish to make a check, I can show you the check. What I will do, I don't want to use the equation 1 for the check. I can use equation 2. This is the equation given. So what I will do, I will show you the check over here. You can actually take this part and feature it over here. So that's what I'm going to do. So let me just use this space instead of going over there. So this is given, 9 of 10 times x positive y is equal to 2 times of 10 times y positive x. If I were to substitute the value of x and y and x and y, left hand side should be equal to right hand side. It will be. So this is 9 of x is equal to 1 and y is equal to 8 is equal to 2 times y is equal to 8, x is equal to 1. So this is going to be 10 times 1 is 10 added with 8 would give me 18 times 9 is equal to 2 times 10 times 8, 80 added with 1 will give me 81. Now if you had to multiply these two things, this is going to give me 2 1s are 2, 8 2s are 16, 9 8s are 72, 7, 9 1s are 9, 9 added with 7 gives me 162. So clearly you can see 162 is equal to 162, hence verified. So that is a good place for us to stop and move to the next question. Students, let's do this question. This is example 14 and it is occurring at page number 23. I will also put in the question and you will be able to see that. The question is reading as follows. From a bus stand, you got a bus stand here where buses are starting from, and you got a ticket center, right? So there are people who are purchasing tickets, and this bus stand is in Bangalore. Now from here they are taking tickets to various cities, and we've been given two such places. One is Malleshwaram and the other place is Yeshwantpur. So a person is buying 2 tickets to Malleshwaram and 3 tickets to Yeshwantpur, and the total cost is rupees 46. Now instead of buying this, if the individual buys 3 tickets to Malleshwaram and 5 tickets to Yeshwantpur, the total cost is rupees 74. Now we are asked to find the cost of the ticket to Malleshwaram and the cost of the ticket to Yeshwantpur. So this is the question. So what I wish to do is I would like to start up the solution in this fashion. I would like to say let x be the cost of the ticket to the first place, Malleshwaram, right? And y be the cost of a ticket to Yeshwantpur. From the question we have been given 2 times x positive 3 times y is equal to 46, and 3 times x positive 5 times y is equal to 74. That's it. Now if they are asking you to use cross product, then this is how you need to do. I'm teaching you a simplest way to extract. After you have formed this, just place a x here and a division line and a y here and a division line and 1 here and a division line. So this is the system. Now we need to fill in the values for x. So do not touch the column, the first column. Don't touch this for column, but use the values that you see here. Now what you need to do is you will have to place in, or I would say you will have to make your decision whether to place these values after the equal to sign or pull in the values inside the equal to sign. So that is your choice. Now what I would suggest you is, if you are keeping it here, then you will have to take in a negative sign. So it would be always better to bring these values into the left hand side. So what I would do is I would write the following system. So this implies you got 2x positive 3y negative 46 is equal to 0, and 3x positive 5y negative 74 is equal to 0. This is what I would do. Now I'm going to treat it as a complete system. So to write down the values of x, do not touch the first column. Multiply this with this. So you got negative 74 multiplied with 3, and when we are moving from the left, you have to take a negative sign with you, and this is going to be 5 into, there is a negative sign there, place the negative sign, negative 46. Now when you come to y, you carry a negative sign, you place the negative sign. That's the form, right? So the form is going to be plus, you start with plus and then you follow it up with a negative sign and then you have a plus. So this is the pattern for cross product. Once you do this, you don't have to worry about any other signs. That's it. So for filling up the value of y, drop this and you multiply negative 74 with 2. So if I were to do that, negative 74, since I don't have space, I will have to restrict my ink size. So negative 74, you can't touch this part, as I mentioned to you, it goes with 2, and when you move to the left side, from the left you got to multiply, so you place a negative sign and then follow it up with 3 with negative 46 being featured there. Okay, so this is negative 3 and negative 46. Now coming to the constant, you got to ignore this column and only handle these elements here. So 5 times 2, you place a negative sign, and 3 times 3. That's it. This is how you do the cross product. Now I'm using this rough side. Let me show that to you. Rough side, I have to multiply the quantities. So 74 times 3, 3 fours are 12, 1, and 7 threes are 21, 22. As in, I have a negative sign, place the negative sign there, and then negative, negative, positive, and that's going to be 5 times 6 is 33, 20, 21, 22, 23. So you subtract these two terms. So 10, you get 8, this is going to be 0, and this is going to be 0, you have 8 here. So this is x over 8. And this is equal to negative y over 4 2s are 8, 7 times 2 is 14. So I'm placing it here, 1, 4, 8, negative sign, and then 6 3s are 18, 3 4s are 12, 13. So this is positive. Now I can subtract these two terms. So this is going to be 0, and this is going to be 10 with a negative sign. So this is going to be a negative sign here. Two negatives, you can change it to positive. This is equal to 1 over 5 times 2, 10, 10 minus 9, that's going to be 1. Now from here you have to consider x with the constant. X over 8 is equal to 1 over 1. So this means x is equal to 8. That's the way you do that. Secondly, you consider y over 10 with the constant term. So this means y is equal to 10. So you have actually obtained the values here. So this means the fare, the first fare xb, the cost of the ticket to the first place. So that would mean this is, let me write the solution. See, final solution, you can name it like this. Solution x is equal to rupees 8 and y is equal to rupees 10. That's it. You place it in a box. That's the final solution, and you can move on to the next question. Now this is an interesting question. This is example 15. The question reads as follows: for what values of p does the pair of equation given below as unique solution? So we have a system given 4x positive p times y positive 8 is equal to 0, and 2x positive 2y positive 2 is equal to 0. Now if you remember, we always used to take pairs of lines in this fashion: a1x positive b1y positive c1 is equal to 0, and then a2x positive b2y positive c2 is equal to 0. For unique solution, a1 over a2 should not be equal to b1 over b2. This is the condition which I have explained to you in the earlier part of this lesson. Please go and check that out. Now, having known this, if we were to assign the values, we can write it like this: from the above equation EQN, we have, you can state it. So you can take the coefficients as a1 is equal to 4, b1 is equal to p. We are not going to be using c1, so you don't have to take c1. If you want, just for the sake of consistency, you can take it as 8. And then you got a2 is equal to 2, and b2 is equal to 2, and c2 is equal to 2, right? So for uniqueness, a1 over a2 should not be equal to b1 over b2. So this would mean 4 divided by 2 cannot be equal to p over 2, right? Now you have to get the value of p. How are you going to get the value of p? Let me show you this trick. You just retain it as 4 over 2 is equal to p over 2. You cross multiply. So this would mean I'm actually trying to find the value of p. This means p is equal to 4 over 2 times 2. 2 gets cancelled. So p is equal to 4. So what does it mean? This means p cannot take this value. So this means for the solution to be unique, p cannot be equal to 4. That's all. That is the requirement. You will have to present it there, and that is the end of the solution. And these things are all important. You will have to be explanatory as much as possible. You cannot simply write down the steps and expect the examiner to give you a full score. So have that in mind. Students, this is a beautiful question. The question reads as follows: for what values of k will the pair of linear equation have infinitely many solutions? So this is example 16, and let us do that question. Now for a pair, what is the requirement for the pair of linear equations? To have infinitely many a1 over a2 should be equal to b1 over b2, and this in turn should be equal to c1 over c2. This is the requirement. Now what are we given? We are given that k times x positive 3 times y negative of k negative 3 is equal to 0, and 12 times x positive k times y negative k is equal to 0. So from here a1 is equal to k, b1 is equal to 3, c1 is equal to, we are actually having a negative sign here, so we need to take that into account. So negative of k negative 3, and a2 is equal to 12, and the b2 is equal to k, and c2 is equal to negative k. So a1 over a2, right? So k over 12, so this means k over 12 should be equal to 3 over k is equal to negative of k negative 3 divided by negative k. This will become positive. Now we need to find the value of k. So consider k, let me write that down here, k over 12 is equal to 3 over k, cross multiply. So this means k squared is equal to 36. This means the value of k. So if k squared is equal to 36, k is equal to root of 36. And we have k to be equal to positive 6 or negative 6. That's what we have here. Now there is one thing whenever you apply the square root function, we generally take the positive values. I don't want to go into much detail, but just for the sake of giving you some information, probably later on when you move up higher levels, then the math would be a little bit different. Okay, so having mentioned this, let me consider these two. Now consider 3 over k is equal to k negative 3 divided by k. Now k can be cancelled here. So this would mean 3 is equal to k negative 3. If you were to move that, you will get k is equal to 6 here. You're getting k is equal to 6 here. Now there is just one problem in cancelling it. You will only get k is equal to 6. You won't get the other value. So don't do this cancelling. Avoid this. Avoid this cancellation, because you are not going to be extracting the other value. So to get the other value, what you need to do is just follow this step. Just follow this step. So just take it as 3 over k is equal to k negative 3 over k, cross multiply. So this would mean you got 3 times k is equal to k times of k negative 3. And from here you get k squared negative 3k is equal to 3 times k. You can take a k out and you can either solve it, or what you can do is you can have this 3k moved inside. So I will just move that 3k there. So this is going to be k squared negative 3k, and on this side you got 0. So let me fill in here. So this is going to be k squared negative 6k is equal to 0. So from here you take k out. So k of k negative 6 is equal to 0. Now if AB is equal to 0, then A is equal to 0 or B is equal to 0. This is the law of algebra. So that would mean k is equal to 0 or k minus 6 is equal to 0, which would mean k is equal to 6. So this is why I asked you, do not perform the cancellation here. So you got k is equal to 0 and k is equal to 6. But if you take k is equal to 0, then we will have an issue. We will have 3 divided by 0 and k minus 3 divided by 0. So that has to be dropped. So eventually k is equal to 6 will be the only solution. So this would mean we drop this, k is equal to 0, we take k is equal to 6. So this would mean k is equal to 0 is the solution. So for the system to have infinite many solutions, k is equal to 6 should be the value. So that is the end of this particular example. We'll move on to doing questions in the exercise. Students, we will work out the questions in exercise 3.5. Now I will be working out the questions which are given in sentential form, because the first 4 questions are simple questions. I've already explained to you the technique along with the concepts, and also I have given example questions in all of these types, so that wouldn't be an issue. What you might have is the issue while handling the sentential questions. So that is the reason I would be doing those questions and leave the top 4 questions which are simple for you all to try, and I'm sure that you all will get the solutions. That wouldn't be a difficult process, but sentential questions are a little bit confusing, so I will be working out them. So to start off with, let me read the first question. A part of monthly hostel charges is fixed and the remaining depends on the number of days one has taken food in the mess. When a student A takes food for 20 days, the price or the payment that she has to make is 1,000 rupees as the total hostel charges. Whereas a student B who takes food for 20 days, he has to pay rupees 1180 as hostel charges. Now they are asking us to find the fixed charge and the cost of food per day. So let us do that. Now I'm going to start off with this fashion. Let X be the fixed charge paid to the hostel. Let Y be the cost of food per day. For the student 1, they are giving it as student A, fixed charge plus she is taking food for 20 days and each day she has to pay Y rupees and that is equal to 1000. For the second student, what E does is, student B, he has to pay X, but E is taking food for 26 days. That has to be multiplied with Y, and the cost E has to pay is 1180. So this is the prices that they have to pay, and this is the equation. Now we can eliminate X, change the sign. So X and X gets cancelled. This is going to be negative 6Y is equal to, I have to subtract 11 from 1180, I'm subtracting 1000. So that is going to give me 180, but this 1180 has a larger value. So I retain the sign, I change these signs. So Y is equal to 180 divided by 6, which means the food per day is 30 rupees. And we are expected to find, so we need to get the value of X. So if I were to take this as 1 and 2, put Y is equal to 30 in 1. You need to show that. So this would mean X positive 20 times of 20 is equal to 1000. This is going to be 400. So 1000 minus 400, which is equal to 600. So X is equal to 600 rupees. So this is what they will have to pay for the rent. So we'll move on to the next question. So let's do question 2. Let me read the question. A fraction becomes 1 over 3 when 1 is subtracted from the numerator, and it becomes 1 over 4 when 8 is added to the denominator. Find the fraction. So let me start off like this. Let X over Y be the fraction. So from the question, what do you have? 1 is subtracted from the numerator and the fraction becomes 1 over 3. So this is the first part, and 8 is added to the denominator and the fraction becomes 1 over 4. We are expected to find the fraction. So this is the equation that we have obtained. So from 1, you cross multiply. This is 3 times of X negative 1 is equal to Y. You distribute 3, so this is 3 times X negative 3 is equal to Y. Bring Y to the left, so this would mean you got 3 times X negative Y negative 3 is equal to 0, and you can take this as equation 3. Now from 2, you got X over Y positive 8 is equal to 1 over 4. Cross multiply. So if you cross multiply, you get 4 times X is equal to Y positive 8. Bring everything to the left. So this would mean 4 times X negative Y negative 8 is equal to 0. Take this as 4. So now you have to solve 3 and 4. So what is 3? This is 3x negative y negative 3 is equal to 0. And 4x negative y negative 8 is equal to 0. Change the sign. I want to eliminate y. So positive. You got a positive here, place negative. You got a negative here, place positive. So y is eliminated. 3x negative 4x will give you negative x. Negative 3 positive 8 would give you positive 5 is equal to 0. Move the 5 to the other side. you get negative x is equal to negative 5. Change the sign, so x is equal to 5. This is the value. Now put x is equal to 5 in 3. You can choose 3 or 4 depending upon your choice. I am choosing 3, so this is going to be, in place of x I substitute 5, and you got a negative y, negative 3 is equal to 0. So this means you got 3 times 15, 15 negative 3 is 12, so 12 negative y is equal to 0, and you can actually move y to the other side, so this would mean y is equal to 12. Now the fraction, so we have taken the fraction to be as x over y, so this means x over y is equal to 5 divided by 12. So that's the answer. Now the next one is a nice question. It's question number 3 we are into of chapter 3.5. It says as follows: Yash scored 40 marks in a test, 3 marks for each right answer and losing 1 mark for each wrong answer. Had it been 4 marks for each correct answer and 2 marks deducted for each wrong answer, he would have got 50 marks. How many questions were there in the test? So I'm going to start like this. Let x be the number of correct answers and let y be the number of incorrect answers or wrong answers. So he's been given 3 marks for each right answer and he's been penalized 1 mark for each wrong answers. So in all he has got 40. So this is the equation for the first part. Second part, if he had been given 4 marks and penalized 2 marks, then he would have got 50. So this is equation 1 and equation 2. Now what I'm going to do is I'm going to take equation 1 and I'm going to multiply by 2. I want to eliminate y, and second equation I multiply by 1. So this is going to be 6x. So equation 1 can be rewritten as 6x negative 2y is equal to 80, and this is 4x 2y is equal to 50. Negative, positive, positive, negative, positive, negative. So this gets eliminated. 6x negative 4x will give you 2x. 80 negative 50 will give you 30. So therefore x is equal to 30 divided by 2, which means 15. So the question wants us to find the total number of questions. And now we substitute, put x is equal to 15 in 1. I'm putting it here. So this is 3 times of 15 negative y is equal to 40. This is 45 negative y is equal to 40. Now push this 40, move that y to the other side. So you get 45 negative 40 is equal to y. So y is equal to 5. So total questions. Therefore, because there is no impact whatsoever if we were to observe with regard to the questions, it's the correct answers stays as it is, the incorrect answers they stay as they are. So there aren't any change, but the scores only gets affected. So these affect, or the effect that is being executed based on the change in the scores has got no implication whatsoever on the number of questions in the paper or number of questions answered by the student who had got correct as versus the incorrect. So that would mean the total questions is equal to x positive y, and my x is 15 and y is 5. So 20 questions are there in the paper. So this is the final answer for the question. Okay, this is question number 4, and it reads as follows. Places A and B are 100 kilometers apart from on a highway. One car starts from A, so a car is starting from A and there is another car starting from B. So they are 100 kilometers apart. So we don't know where they are. So let's just assume they are like that. And then one car starts and another starts from, so one is starting from A, the other is starting from B. If the car traveled in the same direction, so they're going in the same direction at different speed, they meet after 5 hours. So after 5 hours, so this is the time they are meeting. Now on the other end, if they travel in towards each other, they meet after 1 hour. So this is the time that is given. Now they're asking us to find the speed of the cars. Speed of the cars. So we will be using this formula. Speed is equal to distance divided by time, and since the distance is going to be the same, so this would mean distance is equal to speed multiplied with time. So for the first car, we don't know the speed, so I'm going to take it like this. Let x be the speed of the first car, x be the speed of car A. I don't want to take it as A, I just want to take it as car 1. So x be the speed of car 1. So that would mean the time. So this is going to be time versus speed. I've taken x to be the speed. So this would mean the distance is going to be x is a speed, so I have to write it as x times 5, but I will write it as 5 times x. So this would be the distance. And over here, let y be the speed of car 2. Speed of car 2. So this would mean the distance is going to be, the time invested also is going to be 5 there, and this is going to be 5 times y. So we have to club these two systems. So this would mean 5 times x negative 5 times y is equal to 100, and this in turn means x negative y is equal to 20. So this is equation 1. Now having got equation 1, we need to get equation 2. So traveling in opposite direction, traveling in opposite direction. So what happens in opposite direction? This would be the equation. X positive y is equal to 100. So this is my equation 2. So I will have to solve 1 and 2. So x negative y is equal to 20, x positive y is equal to 100. You cancel this, you add this, this is going to be 120. So from here x is equal to 120 divided by 2, which is nothing but 60 km per hour. This is for the first case. And y will be, substitute x over here, and y will be 40 km per hour. So that's a solution. This is a simple question, provided you know how to form the equation. So having given you this, let's go on to the last one. So this is the 5th question. Let me read the question. The area of a rectangle gets reduced by 9 square units if the length is reduced by 5 units and the breadth is increased by 3 units. If we increase the length by 3 units and the breadth by 2 units, the area gets increased by 67 square units. Find the dimension of the rectangle. Now let us do this question in this following fashion. Let length be equal to x for the rectangle, and the breadth, it says breadth, right? I was about to write it as the width. So the breadth, let me write it, let breadth be equal to y units. Now therefore area is given to be as length into breadth. Area is x into y. Now from the first data, it says that the area gets reduced by 9 units if the length is reduced by 5 units. So length is actually reduced by 5 units and the breadth is increased by is increased by 3 units. So this would mean, so this is the system we will have: x negative 5 times y positive 3 is equal to xy negative 9. And for the second one, it's going to be x positive 3 times y positive 2 is equal to xy positive 67. So I'm taking this as 1, I'm taking this as 2. So I need to do some simplification with regard to 1. So x into y positive 3x negative 5y negative 15 is equal to xy negative 9. xy can be cancelled. So you get 3x negative 5y negative 15 added with 9. That's going to give me negative 6 is equal to 0. So this is my equation 3. And from equation 2, x into y, xy, 2x, 3y, 6 is equal to xy positive 67. xy can be cancelled. You get 2x positive 3y. And 61, you bring negative 67, it will become negative 61 is equal to 0. This is my 4. Now you can use any method you want, either elimination, substitution, or cross product. I will be using elimination method. So I'm taking this as 3x negative 5y negative 6 is equal to 0, and 2x positive 3y negative 61 is equal to 0. So what I wish to do, this is 3 and 4. I will multiply 3 with 2 and 4 with 3. So if you were to do that, this is going to give me 6x negative 10y negative 12 is equal to 0, and this is going to give me 6x positive 9y negative 3 1s are 3, 6 3s are 18 is equal to 0. This is what we get, right? So you change the sign, plus, minus, minus, plus, cancel them off, and then negative 10y, negative 9y, that's going to be negative 19y. You got negative 12 and positive 183. So 183, and you add negative 12. So you subtract this, it's going to be 1. And from 8 you take away 1, that's going to be 7 and 171. So it's going to be positive 171 is equal to 0. So 171 divided by 19 is equal to y. So you need to find out the value of y. Now 171 can be divided by 19 if it is 9 times, because 19 times 9, 9 9s are 81, 8 and 171. Yeah, that's perfect. So this divides, so y is equal to 9, that's a solution here. If y is equal to 9, you substitute it in one of the equations here. And when you do that, you get x is equal to 17. If you have to substitute, say, put y is equal to 9 in 3. Suppose you want to do that. This is going to give me 3x negative 5 times of 9 negative 6 is equal to 0. This means 3x negative 45 negative 6 is equal to 0. You add these two things together, you get 3x is equal to 51. And x will be equal to 51 divided by 3. 3 divides here 1 time, 2, 17. So that would mean my x value is equal to 17. This is what we've got. So this is the solution, and probably we can write the solution is equal to x is equal to 17 and y is equal to 9. So that completes our working of those sentential questions. We will move on to the next exercise. Students, we will be doing the next topic, equations reducible to linear equation. So they are giving us this system and they are expecting us to solve, but this is not a linear equation. So this is the form of it: 5 over x negative 1 positive 1 over y negative 2 is equal to 2, and we have got 6 over x negative 1 followed by a negative sign, and 3 over y negative 2 is equal to 1. So this is a system that has been given. Now what we are going to do is we are going to convert this into a linear system. So for that, I'm going to take, let p be equal to 1 over x negative 1, and q be equal to 1 over y negative 2. So you will understand why I'm doing it like this fashion. So if I were to take this as 1 and 2, therefore I can rewrite 1 to be as 5 times 1 over x negative 1 positive 1 over y negative 2 is equal to 2, which can be rewritten using this substitution as 5 times p positive q is equal to 2, right? Similarly, 2 can be rewritten as 6 times of 1 over x negative 1 negative 3 times of 1 over y negative 2 is equal to 1, which in turn can be rewritten as 6 times p negative 3 times q is equal to 1. You see that? So this is the new system. I'm taking it as 3 and I'm taking it as 4. So now you can simply solve it. There wouldn't be any issue. So what I'm going to do is I'm going to take 3 and multiply it with 3 and 4 multiply it with just 1. You can either do it like this or you can multiply it with a negative sign, but I don't want to do that. I just want to ensure the coefficients are same. So that's the priority. So 3 times 5, that's going to be 15p plus 3q is equal to 6. This is going to be 6p negative 3q is equal to 1. We cancel this. 15p positive 6, that's going to be 21p is equal to 6 added with 1 would give me 7. So therefore my p is equal to 7 over 21, which is nothing but 1 over 3. So this is the value of p. So you will get values like this, so you got to be prepared. Now I got the value of p. I need to substitute it in 3. Putting in 3, we get, so what do we get when you put in 3? So this is going to be 5 times of p, that's 1 over 3 positive q is equal to 2. So push this to the other side. So this means you get q is equal to 2 negative 5 over 3. You take the LCM. The LCM is 3. So 3 times 2 is 6 negative 5, which is nothing but 1 over 3. So therefore you get a value of q is 1 over 3. But this is not the end of it. Why? Because we make the following substitution. And now we will have to revert it back. Now I'm going to use this part of the space. So since p is equal to 1 over x negative 1, this means 1 over 3 is equal to 1 over x negative 1, which in turn means x negative 1 is equal to 3. Therefore x is equal to, push this one to the other side, you get 1 positive 3, that means x is equal to 4. So the next part also, q is equal to 1 over y negative 2. You need to cater to that part also. But the value of q is 1 over 3. So this means 1 over 3 is equal to 1 over y negative 2. So y negative 2 is equal to 3. So therefore y is equal to 5. So solution set is what? X is equal to 4 and y is equal to 5. You will have to present the solution. We got to present the solution. Always remember, box them, box them, box them, box them, so that the examiner is aware what you are doing, and give the statements like this, putting it in 3, we get. These are all important parts you will have to learn, because as you go up in higher education, all these representation matters. The more explicitly elaborate you are, the better chances of getting high grades, and grades matter a lot. So this is stream problems, and they are very important. Now we got this question, a beautiful question. A boat goes 30 kilometers upstream. Now this is upstream. Let us imagine this is upstream, and you have a boat that is going, let me show that like that, upstream, right? It is going up. Whenever a boat is going up, you will have to understand this. It's not easy to row the boat upstream, because you got the high level of force which is actually pushing the boat down, and that is why people will avoid going upstream. It's like taking the hard way, and it's not easy. Not everybody can move upstream, and to move upstream it needs effort. It's like working out every day and also working on your purpose. Say if your purpose is to become school topper,
it's not going to be an easy task. So you got to be an A+ student. So you'll have to be working out every day, work out problems in mathematics, and if you want to get 200 out of 200 or 100 out of 100 in mathematics, you will have to put your complete self into it. You got to get immersed and you have to work day out and day in. And that is like rowing the boat upstream. So as I mentioned to you, whenever things are moving upstream, there is the pressure from the water which is pushing it down. So we need to take into account. So this boat is actually moving 30 kilometers upstream. And 44 kilometers, naturally when it goes downstream, if it were to go downstream, it is actually making more distance, so 44 kilometers downstream. And the time taken, the total time taken is given. So time is given to be as 10 hours. So this is condition 1. But they have also given condition 2. Condition 2 is in 13 hours, when the time is equal to 13 hours, the boat is, it can go 40 kilometers upstream. So in this time, it is moving 40 kilometers upstream, and downstream, it is moving 55 kilometers. And we are asked to find the speed of the stream and the speed of that of the boat. So this is a very interesting question. So let me write that down. They are asking us to find the speed of boat and the speed of the stream. So two things have to be found out from this particular question. So what I wish to do is I would like to assign variables. So let me start like this. Let x be the speed of the boat in still waters, and then let y be the speed of the stream. So when the boat is traveling downstream, when the boat travels downstream, the speed will be equal to what? The speed will be speed of the boat plus the speed of the stream. So that is the change. So the stream will also be helping. Next is when the boat travels upstream, the speed will be, from the speed of the boat, you got to take away the speed of the stream. So that is the issue there. Now we will be using this one. This information, time is equal to distance over speed, and distance is equal to speed into time, if you want to use that formula also. So now we are given the following. What are we given? Upstream, when the boat is moving upstream, when the boat is moving upstream, what are we given? We are given, say, T1 is equal to distance traveled divided by speed x negative y. And when the boat is moving downstream, T2 is equal to 44 divided by x positive y. And T1 plus T2, T1 plus T2 is given to be as 10 hours. So this means 30 divided by x negative y positive 44 divided by x positive y is equal to 10. This is one system. I know we have to do a lot of things, so that's why the question is a beautiful question. Now for the second part, okay, we are given another information. Also T1 is given to be as 40 divided by x negative y. This is the second part, right? For 13 hours. When it's going up, it's 40 kilometers. We got to take that. And T2 is 55 divided by x positive y. Also in this case, T1 plus T2 is equal to 30. So this means 40 divided by x negative y positive 55 divided by x positive y is equal to 30. This is my system 2. Now let p be equal to 1 over x negative y and q be equal to 1 over x positive y. Therefore you can write system 1 to be as 30 times p in place of 1 over x negative y. I have explained to you in the previous question. So this is going to be 44 times q is equal to 10, and for the second system, so this is going to be 40 times p positive 55 times q is equal to 30. You can use cross product or whatever information that you want. I think in this case it is better to use cross product because we got huge numbers. So whenever we got huge numbers, cross product is better. So what I will do is, this is the information we have got. We can either push this quantities to the left and handle it, or you can retain it as it is. So what I will do, I will take these things to the left. So this means 30p positive 44q negative 10 is equal to 0, and 40p positive 55q negative 13 is equal to 0. So this is what we have got. Now it's going to be p divided by, leave this entire column and multiply negative 13 with 44. Whenever you're going from the left, you take a negative sign. So 55 times negative 10 is equal to, whenever you place the value for q, you take a negative sign. That's the way the formula is designed. Now you drop this column and multiply negative 13 into 30. Whenever you're going to the left, you place a negative sign. So this is going to be 40 times negative 10 is equal to 1 over, leave this column, and this is going to be 55 times 30 negative 40 times 44. So this is what you have got. Now you will have to perform the simplification, and you will have to calculate these values, and upon reducing you get p divided by negative 22, and with a negative sign, q divided by 10 is equal to negative 1 over 110. So this is what you would get. Now what you need to do, you need to connect this and this. I will be doing that. So p divided by 22 with a negative sign is equal to negative 1 over 110. So this would mean I get p is equal to, you can get rid of the signs. So 22 divided by 110. So p is equal to 1 over 5. So that's one value. Also you can compare this with that. Negative q over 10 is equal to negative 1 over 110. So this means q is equal to 1 over 11. This is the value you have got. But now you go back to the values of the real p which we have assigned. We have taken p is equal to 1 over x minus y. So, but p is equal to 1 over x minus y. So this would mean 1 over x negative y is equal to 1 over 5, and I get x negative y is equal to 5. You cross multiply. And also let me use this part of the space. Also 1 over x positive y is equal to 1 over 11. So that would mean you get x positive y is equal to 11. So you can solve this, cancel these two things. This means you get 2x is equal to 16. Therefore x is equal to 8. X is equal to 8. Take the value and substitute it here. You can write that. Put x is equal to 8. Probably you can name them as say 4 and 5. You got a number then, 4 and 5. Put x is equal to 8 in 4, and we get, you got to give these statements. We get, what do you get? You get 8 negative y is equal to 5. You move y to the other side, bring 5 to this side, it will be y is equal to 3. So the speed, you have got 8 and 3. So go back here, make the conclusion. So therefore speed of boat is equal to 8 kilometers per hour, then speed of stream is equal to 3 kilometers per hour. Okay, 3 kilometers per hour. So you will have to place it and box the result. Okay, I know that this question is little bit lengthier, but that's the way these questions are asked, and they carry a lot of weightage. So you will have to work on this. And if you were to go to exercise 3.6, you can clearly see all of these questions in exercise 3.6 is discussed. I've already discussed these questions, and you can work these questions out. And there is something called as optional. You can also try the optional questions out and give me feedback on the comment box. So this completes our study on chapter 3, students. And if you have any queries or questions, please place your comments. Thank you, and until we meet again.